All right, let's wrap up this review with problems 9 through 18. We are factoring. We're looking for two sets of parentheses that produce the trinomial that you see here. I know that x times x is x squared. I know that it's going to be a plus plus here and a plus plus there. I need two numbers that multiply to make 44 and add up to 15. 4 and 11 will do the trick. You can check your work by either graphing both of these or just foiling this and making sure you get your original problem. Number 10, I need x times x to make x squared. I need a double negative so that they're going to multiply to make positive 12 and then add up. Watch this. If I get a negative 4x and a negative 3x, notice that combining like terms will make that negative 7x in the middle. 11 and 12. Ready? Now we have a negative c term, a negative constant on the end. We're still going to have x times x, but we're definitely going to have a plus and a minus because these two numbers need to multiply to make negative 16, and they need to combine to make positive 6. I think it's going to be a positive 8 and a negative 2. We know they make negative 16 when multiplied. Check out the inside, 8x, and the outside, negative 2x. Combine like terms, voila. There's your 6x in the middle. 12. We're definitely going to have a plus and a minus again because of the negative 18 on the end. This time, the negative needs to win, or the negative needs to end up in the middle. So when you figure out your factors of 18, which are, by the way, 9 and 2, I know that 9 is going to be negative because when I do my outer negative 9x and my inner 2x, notice that they combine to a negative 7x. 13. Difference of perfect squares. Whenever you have the difference of perfect squares, it's just x plus the square root of 49 and x minus the square root of 49. That comes true again in 15. It's just x plus 4 and x minus 4. I skipped 14 for now. I jumped over to 15, x plus 4, x minus 4. 14 is called a perfect squared trinomial. You know it's a perfect squared trinomial when your c term is a perfect square and the square root of it, 10, is half of the number in the middle. So it's going to be x plus 10, x plus 10. We can rewrite that as x plus 10 squared. Similar thing happens in 16, where it's x plus 5 and x plus 5. And you can write that as x plus 5 squared. In 17, this will be a two-step problem. When you have that leading 2 out in the front, you want to see if you could divide out that 2 from all three of these terms. I can divide out that 2 and put it out front, leaving me with x squared plus. Divide the 22 by 2, you get 11x plus. 48 divided by 2 is 24. So we factored out the common factor 2. Not quite done yet. We still need to factor that trinomial that still exists, if you can. Sometimes you can't, sometimes you can. This one you can, because 8 and 3 multiply to make the 24 and add up to make the 11. 18 is a little different because there's no c term on the end. There's a 0 out here. The easiest way to do these, I think, is to focus on these two terms, 4x squared and 16x. See if they have a common factor, and they do, 4. And see if they have a common variable. They do. X. X is the common variable that they have, so we can bring that out and sort of undistribute it. You want to think about what would be in here that you would distribute to produce 4x squared plus 16x. 4x would be multiplied by x to make 4x squared. 4x would be multiplied by 4 to make the 16x. This is my final answer in number 18. Your quiz tomorrow will be very similar to this review. It may have a few more challenging problems, but this is This is it for the most part. Good luck.